person who falls into a black hole never truly dies. At least, that's how it appears to outside observers. They would seem frozen forever at the edge of the black hole, like a still photograph. But their own experience is the complete opposite. They would be torn apart in less than a second. And from their perspective, the entire universe would be wildly accelerating. Billions of years of history would flash before their eyes. Until finally, all the stars go out at once. That's the most terrifying thing about black holes. They don't just kill you. They force you to witness the end of the universe. But things get even stranger after that. Scientists have recently discovered that black holes may not truly destroy everything. Every piece of your information, every memory, every thought may be encoded on the surface of the black hole. Like words carved into a gravestone, never to be erased. What does that mean? It means that you, after being swallowed by a black hole, may not have truly disappeared, but instead become part of the black hole itself, existing in a form we can completely fail to comprehend. Now, let's start from the beginning. What exactly is a black hole? And how are black holes born? The answer lies in the death of stars. When a massive star, with more than 20 times the mass of the Sun, reaches the end of its life, its core fuel is exhausted. It can no longer generate enough thermal pressure to counteract its own gravity. At that moment, the star's core undergoes gravitational collapse. In less than a single second, the outer layers fall inward at incredible speeds. The energy released by this collapse is so immense that, within seconds, it outshines the combined light of all the stars in the Milky Way. This is a supernova explosion, the most spectacular fireworks display in the universe. But the truly terrifying part comes after the explosion, when the core matter is compressed past a critical point. All atomic structures collapse. Protons and electrons are crushed into neutrons, and eventually even neutrons can no longer hold out. At this stage, under the framework of general relativity, no known physical force can stop gravity from compressing further. Matter collapses into a point of infinite density and zero volume. A black hole is born. You might ask, how many kinds of black holes are there? Strangely enough, there are 3 completely different types of black holes. The first type is stellar mass black holes, formed from dying stars like the ones we just described. They typically have masses between 5 and 100 suns. The second type is supermassive black holes. At the centers of galaxies lurk monstrous objects with masses millions, or even billions of times that of the Sun. How these black holes formed remains one of the greatest mysteries in astronomy. Scientists have proposed a bold hypothesis. In the first few 100 million years after the universe was born, there may have existed primordial gas clouds with masses tens of thousands of times that of the Sun. They never went through normal stellar evolution, but collapsed directly under their own gravity, forming the seeds of black holes. The third type is intermediate mass black holes, with masses between 100 and 100,000 suns. They may represent a transitional form between stellar mass and supermassive black holes. In 2020, scientists confirmed for the first time, through the gravitational wave event GW190521, the discovery of an intermediate mass black hole with about 142 solar masses. A black hole's appetite is never satisfied. After a black hole is born, it grows wildly in 2 main ways. The first is devouring matter, when gas, dust, or even stars approach a black hole. They are torn apart and form a rapidly spinning accretion disk. Within this disk, matter moves at speeds close to that of light. friction heats it to hundreds of millions of degrees Celsius. The X-rays and gamma rays released are so intense that we can detect them from billions of light-years away. In 2011, astronomers directly witnessed the complete process of a star being torn apart by a black hole. That spectacle lasted for several months. The second way is black hole mergers. Mergers between black holes are even more violent. On September 14, 2015, humanity directly detected gravitational waves for the first time. They came from two black holes with masses of 29 and 36 times that of the Sun. Located 1.3 billion light-years away, as they completed their final dance of death, they orbited each other at half the speed of light. Until finally, they merged into a single black hole with 62 solar masses. The remaining 3 solar masses were entirely converted into gravitational wave energy and radiated into the universe within 0.2 seconds. In that instant, the power released exceeded that of all the stars in the entire observable universe combined. Here's a counterintuitive fact. Black holes are not destroyers of the universe, but its architects. Astronomers have found that, at the center of nearly every large galaxy, there is a supermassive black hole. Moreover, the mass of the black hole and the mass of the galactic bulge follow a precise proportional relationship, roughly 1 to 1,000. This means black holes and galaxies co-evolve. When a black hole devours matter, it ejects 2 jets of high-energy particles perpendicular to the accretion disk. These jets travel at nearly the speed of light and can extend for hundreds of thousands of light. The energy carried by these jets heats the gas within the galaxy, suppressing new star formation and regulating the overall pace of galactic evolution. Without this black hole feedback mechanism, galaxies would rapidly turn all their gas into stars and then quickly die. In this sense, black holes are the heart and brain of galaxies, controlling their ultimate fate. Do black holes themselves die? The answer is yes, but the process is so long it feels hopeless. In 1974, the young physicist Stephen Hawking proposed a revolutionary theory. He discovered that black holes are not completely black through quantum effects. They slowly radiate energy outward. This is the famous Hawking radiation. But this radiation is terrifyingly slow. A black hole with the mass of the Sun would take 10 years to fully evaporate. The universe itself is only 13.8 billion years old. The black hole at the center of the Milky Way, with 4.3 million solar masses, would take even longer, around 10 years to evaporate. By then, all stars in the universe will have gone dark. All galaxies will have dispersed, and even protons may have decayed. The entire universe will sink into eternal darkness and silence. Black holes will be the last celestial objects to die. Their evaporation will be accompanied by one final, faint flash of light, and then everything returns to nothingness. Humanity's exploration of black holes has only just begun. On April 10, 2019, the Event Horizon Telescope team released the first image of the black hole at the center of galaxy M87. That golden ring stunned the world. On May 12, 2022, we captured an image of Sagittarius A*, the black hole at the center of our Milky Way, right in our cosmic backyard. And the rise of gravitational wave astronomy has given us the ability to listen to the sounds of black hole collisions. According to data from the LIGO-Virgo collaboration, by the end of 2023, humanity had detected more than 90 gravitational wave events. New black hole mergers are being discovered almost every week. Future space-based gravitational wave detectors, such as LISA, the Laser Interferometer Space Antenna, will detect even more distant and more massive black hole mergers. helping us understand the universe's early history. Unsolved mysteries remain. Black holes still hide countless secrets. What truly happens at the singularity? Do black holes connect to other universes? Does information really disappear forever inside a black hole? The answers to these questions may require us to develop entirely new physical theories, perfectly unifying general relativity and quantum mechanics. And when that day arrives, our understanding of the universe's true nature will undergo a revolutionary leap. Remember black holes in 3 sentences. Black holes are not holes, but the ultimate prisons of space-time. Black holes are not destroyers, but the architects of galaxies. Black holes are not eternal, but they will be the universe's final witnesses. Black holes, the most extreme objects in the cosmos, are telling us, through their very existence, that reality is far more insane than we imagine and exploration never ends.